Hello, good morning. This is Aurora, and let's see if I can pull myself up here. Hello. Give me a smile if you can see me. Great big smile. All right, I thought we would do a quick game. Do you guys like playing games? Me too. All right, do you remember, whoop, wrong screen. Do you remember when we learned about how to play bagels? Okay, so if you don't remember or it's been a while, oh gosh, I don't even know when Mastermind came out, but it's an audio version, so you can play it just standing up, you don't need anything, of Mastermind. It's basically a 2-digit number that you're gonna guess using logic, and usually you can get it in like 5 or 6 guesses or less. So I'm gonna write a number down here, and I'm going to, there we go. Okay, so I've written it down so you can't see it, and then let's walk through how to do it, all right? Let me grab a sheet of paper so I can, that sounded much worse than it was. Lots of crashing. Okay, so good morning. How was your weekend? Did you have a good one? Mine was too short. Last night I couldn't believe that, oh, you can't hear. Uh-oh, give me a thumbs up for good audio. Can you hear me? My audio is playing, looks like it's good here. Let me make sure it's good. Yeah, it looks good. Okay, so you need to turn up your speakers, but if you can't hear me say that. Okay, so let's do a, we're gonna guess a 2-digit number. Wait, before you start guessing, I already got guesses. Hang on. All right, so it's gonna be 2 digits, and then we're gonna walk our way through the number line. So what are the first 2 numbers starting with 1? 1 and 2. All right, so you'd guess 12, you'd say Aurora 12. So you're going to guess not 11 because you want to guess 2 numbers. You want to make this faster, right? Because, you know, we got places to go and things to do. All right, so you're going to guess 12. I'm going to say bagels. Now, bagels means wrong number, wrong place. So what does that tell you? That tells you that there's no 1 and no 2 in my number. So you can already wipe out all the 1s and 2s from this 2-digit number from 00 to 99. Okay, that's useful information. What are the next 2 numbers in the sequence? So instead, after 1 and 2, what else do we have? Just walk your way up the number line. What else do we have? Yeah, we have 3 and 4. Okay, so you're going to say, Aurora, 34. And I'm going to say, bagels. What do you know? Bagels means wrong number, wrong place. Okay, so you know there's no 1, 2, 3, or 4. That's really useful information. Would you agree? In just 2 guesses, you've wiped out a lot of the possibilities in it, like 52, that can't be it because there's no 2. 61, can't be it, right? Okay, so let's guess the next 2 numbers. So we guessed 1, 2, 3, 4. What's the next one you want to guess? Yep, that's right, 5 and 56. Good. So you'll say 56. I'm going to say pico. Uh-oh, I said something different. Pico means right number, wrong place. Question, do you have enough information to know if it's the 5 or the 6 I'm talking about? Shake your head no. Don't know. So we have to test. And you can test lots of different ways. You can say, all right, I'm going to guess maybe a number I do know that's not in there, like 51. Or I can guess 57. You know, hold one of these constant and then change the other. Or I could guess, I could put the 6 over here and say 61, something like that. So you can test. So what would you like to test with? What would you like to do? Okay, I'll just pick one of yours. Somebody wants to do 63. All right, so we're going to do 63. I'm going to say bagels. What do you know? You know there's no 6, and you already knew there was no 3. Okay, so what does that tell you? Remember, this one was pico, P-I-C-O, pico, really, really small. Pico, what does that mean? Right number, wrong place. Well, if you know there's no 6, what does that tell you about the 5? We already know what position, we know there's a 5, and we know what position it's in. The 5 goes not in the 10s, but in the 1s, because it was pico. So 5 goes up here. We only have 1 more digit to go. All right, what's the next 2 numbers you want to guess? All right, so we did 1, 2, 3, 4, 5, 6. Who's next? I already see people writing it down. Good. 7, 8. Guess 78? I'm going to say pico, and I also say you only have 1 guess left. Now, if I say pico, do you know if it's the 7 or the 8? You do know. That's right, because if it's the 7, pico means right number, wrong place. That means the 7 should go here, but that one's already taken. So what do you know for sure? What's the final answer? That's right. It is 85. 5. And this was the number I had down on my desk. Yay! So as you get good at this bagels game, which is, I didn't invent it. I don't even remember who invented it. It's old. But you know, we'll be in line at the grocery store, or we'll be doing something. And then I didn't tell you the last one. Fermi means right number, right place. So if you had guessed 87 instead, I would have said Fermi. And that would have meant the number was in the right place. So you would have known the 8 was there. Okay, so there's pico, Fermi, and bagels. And when you really get rolling, you sound like an absolute crazy person, because the two of you are pinging back and forth, and I guarantee you people will stop what they're doing and stare at you. And that's usually what happens to me. And I've gotten a couple of lines over the years that work really well. I'm like, yeah, look, no batteries required. Parents will look at me like, what are your children doing? That obviously look like they know what they're talking about, and they keep going back and forth. And like, yeah. And you can do this with 3-digit numbers when you really want to go crazy. So yeah, so that game is called Bagels. You can look it up on the math website. You just search for it. You can also go to the math resources. There's a whole mental math series in there that you can look at. So that's a fun one to do. Don't you agree? Yay! I love games. I don't know if you could tell from the website, there's like math games all over the place. Okay, speaking of which, looks like I've still got my astronomy gear out. Okay, let's go ahead and get started. You guys ready for today? All right, today is all about circles. Hello and welcome to the geometry course for grades 4, 5, and 6. Today we're going to focus on my favorite shape. One of my favorite shapes is the circle. So circles are really unique. They don't have any lines. They don't have any edges. They don't have any vertices. So they're kind of a special situation, which makes them so much fun to deal with. Okay, and to handle and answer questions about. And there's really just a couple of formulas we're going to do today. We're going to show you what the formulas are. We're going to show you how to work with them. And by the end of class, you are going to be zooming around a train track, going up and down on a merry-go-round. You're going to have a lot of fun during class. Okay, so let's flip over. If you have the handout, it looks like this. If you don't have the handout, you don't need it. Just grab a sheet of paper, and we are getting ready to get going. All right, so first things first, if you have the handout, it'll just say a circle is a round shape with no corners or line segments. That's pretty much what we just talked about. Okay, so here we're just going to draw some circles. So on your sheet, you can have a blank sheet of paper. You can draw some circles, any kind of circles, baby circles, big circles, just kind of get in the mood for circles. Got it? All right. That was the easy part. Okay, so now what we want to do is we want to start to define parts of a circle. So even though there's no line segments, there are parts. Number 1, the center. Okay, got the center? Good, and I can actually show you later how, I don't know, I think you've already had this lab where you can find the center of the circle. Okay, so just kind of eyeball the center of the circle. There you go. A diameter is a straight line that starts on one side of the circle, passes through the center, and goes to the other side. That is called the diameter. If it does not pass through the circle, that is called a chord. And we don't usually use chords till we get to calculus. Okay, so just know that we're looking at diameter here. All right. Okay, now if I start in the middle and just go out, I don't go from one side to the other side through the center. That's called the radius. So draw a circle, then find the middle, and start in the middle and go to any point that you want that's on the circle. This is called radius. If you have more than one radius, it's called radii. So radiuses. Okay, so any point that I draw from the center to any point on the circle, it's always going to be the same measurement. So if it's 3 inches from the center to here, it's 3 inches here, 3 inches here. Okay, a circle that this line, the boundary here, this is the same distance anywhere on it from the center. Okay, so how are we doing so far? Good, we've got some circles. Diameter is straight across through the center. Radius is starting at the center to the end. Okay, so that means that the diameter is equal to 2 radiuses, radii. So I have a radius from here to here and another one from here to here. So if I put those together, I get the diameter. So you can see I've got 2 radii. All right, circumference. Circumference is when you build a fence and you go all the way around. We call it perimeter. On a circle, it's called circumference. Okay, so it looks like this. You start here and you make one lap around the track. Okay, and that's called the perimeter or circumference. It's the distance measured around the entire circle. Okay, and there's a formula that relates radius with circumference, and we're going to write it together. You ready? Okay, so you can write circumference is like perimeter to remind yourself, because circumference is a long word to spell. And then what we're going to say is the circumference is a large C equals 2 times pi times r. Okay. All right, and if you do have questions, do put them in the chat, but please only put your comment or question once if you'd like to stay in class. Alessandro, I'm looking at you right now. Good. Pi is just a number. It's close to 3. Anytime you see it, you're going to substitute this number in for it. We're just going to take it out to 2 decimal places, 3.14. Okay? It's just a number. Okay? All right. And if you are worried about your big C not looking like your little c, you can also put tags on it. When we get going, sometimes we'll have big C and little c in the same equation, but they are different things. So if you want to put little tags on the end, you can. Otherwise, just write C. That's what everybody does. All right, good. So if it's, do you see the 2 and the r in here around the pi? You see the 2 and the r here? Look. Circumference is also equal to pi times diameter. And diameter, I'll just use little d. All right, so don't worry too much about, whoa, where did these come from? We get to that a little bit later. I'm going to show you how to use them. You know, it's kind of like electricity. You don't need to understand how it works, but you know how to flip on the switch and make good use of it, yeah? Okay, so let's take a look at another page. So flip your book open to the next page if you need to. All right, so draw yourself a circle, or you can use mine. And then let's find the radius. Let's put it in. Radius is here. All right, now we're going to talk about something called area. Area is how much space something takes up. And for us, the area of a circle is how much space the circle takes up. And the circle ends here at the circumference. So that yellow region there, I can calculate it with a formula. Area is A, and you know how we found area of a triangle, area of a rectangle, area of a trapezoid. Remember that so far? Area of a parallelogram. Now we're going to find area of a triangle. And anytime you see area, you should be thinking, anytime you think of circles, you should have pi in there somewhere. Okay, and it has to do with the fact that the circle's round. So for a rectangle, remember area was length times width, but you can't do that here. So what we do is we take our radius and we swing it around. Okay, so let's practice. Can you draw me a circle? Draw me a circle, and then label it with a radius of 5 inches. Okay, 5 inches. Okay, and so the radius is, make it nice and big, 5 inches. I want to find the area. So we're going to use this formula. This is our area formula. Okay. We'll even box it so it's nice and clear. This is area. You wouldn't believe how many kids try to use circumference for area. Okay, so here's our area formula. Let's find the area. Pi r squared. So write the formula first. Okay, let's take it step by step. My area of a circle is pi. This is a number, a little bit more than 3. So just write down 3.14. That's what pi is, right there. Radius is 5 inches, and squared is here. Now, if you're new to squareds, okay, let me grab another piece of paper. So if I were to say 5 times 5, you could tell me from your multiplication table that's 25. 3 times 3, that's 9. Okay, another way to write this is 5 squared. That little 2 means multiply this number by itself that many times. Right? Because if I had done 2 to the third, that would mean you take that 2 and multiply it by itself 3 times. You see that? This little thing is called an exponent. So 2 times 2 is 4. 4 times 2 is 8. Okay, so that's what that squared means. We're only going to be dealing with squareds right now. Okay, we're going to get to exponents in a few weeks. Okay, so this is, my area is 3.14 times 5 inches times 5 inches. So I'm just expanding this out. And then grab your calculators. Okay, you definitely need a calculator for this, for circles, because we have this 3.14 business. So take 5 times 5. You can do that in your head and then just write, type in 25 times 3.14 equals, I have 78 point, wow, that point is too high. 78.5, and my units are inches and inches, so it's going to be inches squared. And there you go. So that's my area of a circle. Okay. All right, so this is area equals pi r squared. So that's how we pronounce it. Area equals pi r squared. Remember, pi, it's just a number, 3.14. All right, does that help? Okay, so let's practice. Let's find the area for a 4-meter diameter circle. I want you to learn to draw things out first. Diameter means it goes across, right? So this is 4 meters. If it's 4 meters all the way across, how much is the radius? Just for practice. Well, it's going to be half of 4, which is 2 meters. Okay. All right, let's find the area. Area is pi r squared. Okay. So my area is going to be, pi is a number, 3.14. And what's my r? Is it 4 or is it 2? Show me with your fingers. I got zoomers on here. Show me with your fingers. Is it 4 or is it 2? What do I want to put in here? Be careful. If you put too much, it's not going to be happy. You're going to get the wrong answer, and we got to do it all over again. This is r. Okay, so this is why we're drawing it out, so you can see what this says. This says 4-meter diameter, so that's what we drew. Okay, but we want the radius. The radius is half. It's just one of these. So that is 2 meters. And then don't forget, we got to square it. So let me rewrite this so it's a little clearer. 3.14 times 2 meters. Squaring means you just multiply it by itself again, like this, 2 meters. Okay, so 2 times 2 is 4. Okay, and then times 3.14. Okay. So I have, my area is 12.56 meters squared. Somebody's asking about the notes. Yes, don't forget, I actually scan all my notes when we're done, and then I attach them to your handout. So if you just want to watch, that's okay, or if I'm going too fast, just know that you'll have all my notes when we're done. Good. All right. Now let's have you set this up. Can you draw me the next one? Find the area of a 16-centimeter circle. Do you have enough information? You should be shaking your head. What is 16 centimeters? You got 3 possibilities. It could be the perimeter, so the circumference. I could be talking about the radius or the diameter. What did I tell you in the problem? Read the problem. What does it say? Find the area of a 16-centimeter circle. No idea. So I'd have to tell you. So in this case, I'm going to tell you its diameter. Is that enough? Do you have enough information now? Good. Go ahead and get started on the problem. Okay, yep, I'll give you another 8 seconds. Keep going. and then tell me what you get. Okay, so my area, the formula you can just write down, pi r squared. All right, area is, pi is a number, 3.14. R, what is R? R is not 16. Half of 16 is 8. That is R. And then we're going to square it. Don't forget to square it. Okay, so my area is, let's write it out, 3.14 times 8 centimeters times 8 centimeters. Area is 8 times 8, I can do that in my head, 64, times pi. My area is 200.96. My units are centimeters squared. So just like before, area is always in square units. Do you see how this is different than doing a triangle, different than doing a rectangle? Okay. How are you guys feeling so far? How are you feeling with this? Good? Okay. So that's pretty much as far as we're going to go. It's like, okay, we're done already. It's only been 15 minutes. Now we're going to practice. Okay, so we're going to take things, we're going to go back, forwards, inside out, and just make sure we're really, really confident in doing this. It's like maybe learn, I don't know, the first time you learn something, and then we make it nice and simple, and then we're like, okay, now let's try it in different situations. So that's what we're going to do. So do you have your ruler? Grab your ruler, and then flip over to page number 3. All right, so page number 3 looks like this. Now, I want you to find me the diameter and the radius of the circle. Well, because it's a circle, that can be a bit of a challenge. So, and I didn't even tell you, is it inches? Is it centimeters? Okay, so I want it in centimeters. Okay, so flip over to the centimeter part of your ruler. And here's the easiest way to do it. So you watch the 0, and you start at the top, and you bring it down, straight down, and you get to a point where you see it is the fattest here, and it comes out to the largest number here. And this might take you a few tries, especially since the center is not marked. Okay, so you see here it doesn't actually hit the 0. So I need to come over, get it to hit the 0. Okay, and then I'm going to hold it, and then I can pivot it up a little bit and pivot it down. Oh, keep it on the 0. And I want the largest reading over here. Okay. All right, so you try that now. And by the way, you're going to have to do this again for the small circle. Okay, so what do you read? Okay, so you can use my ruler here. Read it. Yes, so the diameter is, here's the center. The diameter is 4 centimeters. So what's the radius? Do we have to measure it, or can you just tell me? Which one? Yeah, it's half, right? Because the radius is from here to there. So here's one radius, there's another radius, put them together, and you get diameter D, and this is radius R. D is diameter, R is radius, and that is going to be 2 centimeters because it's half. Good. Now, let's do it for this one. Find the circumference of the circle. Circumference. Okay, so let's write the formula for circumference first. Do you remember what it was? C is equal to 2 times pi times r. That's one of the equations. The other one that you may use is pi times d. They will both give you the same answer. Okay, so you have your pick. Do you want to measure radius or diameter? Well, for a circle that doesn't have a center marked, diameter is going to be easier to measure. Okay, so get your ruler out and go ahead and measure it, and then I'll help you measure it in just a minute. I'll give you a 10-second head start. Okay, go ahead. Okay, so for me, I'm gonna kind of slide it around. Okay, there's my 0. Kind of make it as pudgy as I can. I'm reading about just a hair under 2.5, so I'm going to round up. because it's not perfect, just like the real world. All right, so I'm going to say it's 2.5 centimeters. Do I need to find the radius? Yes or no? What do you think? Do I need to find it? No, I don't need to, because I've got the diameter and I'm going to put it right in there. So you can if you want. Okay, so my circumference is I don't have the 2 because that's for the radius. So it's pi, which is a number, 3.14, and d. D is 2.5 centimeters. Okay, so spend most of your time figuring out what the problem is asking, doing any measurements if you need to, figuring out, okay, and double checking yourself, is that the right equation? And then this last part is the one everybody wants to jump to because then it gives you the answer. But keep this for the last second. I always check my work before I bother with calculations, because if I mess this up, then it doesn't matter what the answer is. So I just make sure, yeah, okay, that looks right, that looks right. Okay, now I can go ahead and calculate. Okay, so I've got 3.14 times 2.5. All right, so I have 7.85. What are my units? Okay, I only have 1 centimeter here, so it's just centimeters. And if you think about it, it makes sense because circumference is something, it's like you taking a ruler and going all the way around once. So it's not area. Area would be centimeters squared. Circumference is always a linear measurement. It's only, it's a ruler. Okay? Okay, so how many of you like to go for a walk where in a forest? Anyone like trees? Got some tree loving people out there. I love trees, especially because they're fun to climb. As a kid, you would always find me up in a tree with a book. Usually, sometimes it was a math book. Oh, actually, I can show you right now, here, while you're looking at that. There you go. I'd be up in a tree with one of these. This is a math puzzle book. Yes, everybody's got their thing. Don't judge. Maybe you'd be in the kitchen using your math skills. Okay, so let's go. Let's go back to the problem. All right, tree trunk. I can take a tape measure and wrap it around and measure it. So we always draw pictures when we're doing word problems if we can, because it just helps us understand the problem better. Okay, so a tree trunk measures 14 inches around. So where is that? Is that diameter? Is that radius? What are we talking about here? Yeah, around. So take your tape measure and go around. That's 14 inches. So what is that? Call that perimeter or circumference. Circumference is 14 inches. Okay, that's handy. We don't have to calculate it. They gave it to us. What do they want to know? What is the diameter of the tree? Uh-oh. Diameter of the tree. Here, let me highlight the actual tree. There we go. Diameter. What does that mean? That means from here to here. Remember, from one point on the circle through the center to the other is diameter D. That's what we want to know. Well, how do we do that? Well, we start thinking about what we have available. So we have 2 pi r. We have circumference and pi d. Do you like any of these yet? Area is pi r squared. We got lots of things available. Which one do you think fits best? Number 1, 2, or 3? Here, 1, 2, or 3. Which one? Well, I have circumference. Okay, great. This is not an area problem, so I would get that off the table because that's going to be confusing. All right, and they want diameter, not radius. So I would go with door number 2. Okay, so let's write this. So my circumference is equal to pi times d. Now I have this. This is 14 inches equals pi is 3.14 times d. So d times 3. So something times a little more than 3 gives me 14, but I don't know what that is. All right, so hang on tight if this is new for you. Do you remember when we did fractions and we talked about how if I did 5 over 5, do you remember what that is? Yeah, so the 5 on the bottom means how many divisions do you have? And the 5 on the top, this is how many slices of cookie pizza you ate. So if the numbers are the same, that thing equals 1. All right, and that's true for any time the top and the bottom are the same. 3 over 3 is 1, 2 over 2 is 1, 1,000,000 over 1,000,000 is a lot of zeros. That's 1, right? That also equals 1. If the number of divisions equals the number that you're talking about, that's always a whole unit. Okay, remember that so far? Give me a smile so I know this is good. We're good here? Okay, so then watch this. If I say circumference is equal to pi times d, I want to get this d by itself because I want to know what the diameter is. The only way I can do that is to get rid of pi. Now if I subtract it, that won't help because the pi is being multiplied here. So what I do is I say, I remember fractions. Look, what if I divide both sides by the same thing? And I can do that because whatever I do to one side, I got to do to the other. What do I get here? Pi over pi, even though it's an irrational number, what do I get? Show me one finger. Your index finger. Yes. Yeah, this is equal to 1. Exactly. Right? So I have 1 times diameter, so diameter equals, and I have c over pi. I'm allowed to do that because whatever I do to one side, I have to do the other. So I have rearranged my circumference equation to solve for diameter. All right, and if that made absolutely no sense, just write this one down. You now have this equation you can use if you need it for your homework this week. Okay? Okay. All right, so here we go. So I'm going to multiply both sides by 3.14. That's what I did on the other piece of paper. Okay? And this goes away because it's the same number top and bottom. D is the only thing left, equals 14 divided by 3.14, which is 4.4, oh boy, right? This is going to happen because we're working with pi. I would round it to the nearest hundredth. So we take a look, there's an 8 here, so that tells me the 5 goes up to a 6. So diameter is 4.46 inches. So isn't that cool? You don't have to chop down the tree to tell me what the diameter is. 4.46 inches. Yeah, all I need is, and so they actually have pi tape. Oh, I didn't bring it. It's sitting over there. And it's got pi built into it, so you can wrap it around. And everywhere, every reading on the special ruler actually has already divided that number by pi. So you can just read the diameter straight off it, which is super fun. All right, how are we doing so far? Okay, question. How many of you play with toy trains or know somebody who loves toy trains? Okay, well, you all know somebody because that would be me. I love toy trains. All right, so our next problem is a toy train problem. Now, if I were to give you a whole bunch of track, what kind of track would you make? Imagine you're 4 years old. Okay, show me the shape of the track that you probably would make if you're really, really young. Yeah, well, initially it might be like a really long straight one. You're like, wow, look at all these pieces, they go together, right? And then eventually you realize you put the train on this side and it goes shooting off the end. So there comes a time in every little kid's life when they make their first little round track, right? You can imagine that. Okay, so imagine we have that kind of track. I know now you guys would make this super complex, super amazing track that everybody would want to come see. Not that track. Let's make it easy. Okay. All right. So let's take a look at this train track. And you can see it at the top of page number 4. All right. So page number 4 has our train track. Can you imagine building a little one like that? Okay. It happens to be a large one. What is the diameter of my train track? What is my diameter? Yep, it's 10-inch diameter circular track. So usually they mean from the center to the center of the circle to the center of that track. So 10-foot diameter. So that's a big track. How big are you? Are you 10 feet? Probably not. So I don't know of any human being that's 10 feet. So you could literally put an entire person, probably 2 of you, from head to toe, and that's how big this track is. Okay, so how far does a toy train travel every lap if it's a 10-foot diameter circle? Okay, somebody said I'm only 4 feet 11. Okay, so you're close. You're close to half the, you're almost the radius, right? Okay, so how far does this toy train travel? Ooh, let's see. Here, we can even put the train on it. Yep. Choo-choo. Here's a little smoke coming out of it. There we go. There you go. Perfect. Okay. So if the equations we have are these two, 2 pi r, and circumference is pi times d. So my diameter is 10 feet. So I want to use this one. Do you see how it's easy to use this one if you wanted to? You could just divide this in half and put it in here, but then you have to multiply by 2 again. So either one is fine. Either one. Okay, so we're going to use this guy. So my circumference is equal to pi, which is 3.14. And what's my diameter? Can you guys shout it out for me? What's my diameter? Yep, 10 feet. Okay, who can do this calculation in their head? Do you need a calculator for this one? No. Just slap it down. 31.4. What are the units? Extra credit if you get the units right. What are the units? Feet. That's right. So every time our train goes once around, it goes 31.4 feet. What if it goes twice around? How far does it go? It goes 2 times 31.4, 62.8, right? So it goes twice. What if it goes 10 times around? What happens? 10 times around, you move the decimal point over, it goes 314 feet, right? So you take this number because this is how many feet per lap, per once around the track. Good, good, good. How many laps does it take for our train to go 500 feet? Oh, now we're on part B. Okay, so we just talked about 1 lap, then 2 laps, then 10 laps. So if I am taking 500, I want to know 500 feet. This here is a conversion. So I'm going to put feet on the bottom so it cancels out. 31.4 feet per 1 lap. 500 times 1 is 500, divided by 31.4, which is the reason they invented calculators. See if you can see my calculation. There we go. 500 divided by 31.4. All right, can you round that number up to the nearest whole number? It says 15.923566, right, it keeps going. Yeah, so it's about 16 laps. So every 16 laps, how far does it go? 500 feet. How many laps does it need to do to go 1,000 feet? Well, 1,000 is 2 500s. So 2 16s, 16 times 2 is 32. Good. All right. So those are fun. Those are fun. Okay. Who here likes flowers? Do I have anybody who likes flowers, gardening? Anybody like to eat things like berries, fresh peaches? Okay, now I'm getting more of you. Great. We need a garden. Yeah, we need a garden. So let's plant one. How much space do we need? Okay, so we're going to make it a circular garden, of course, because we're talking about circles. 28-inch radius. Can you draw it on my circle? 28-inch radius. Is it this dimension? Is it that one? Which one is radius? Do you remember? Uh-oh, we're in trouble now. How about this? Does that look like a radius? Or does the blue one look like a radius? Which one? Ah, that's supposed to go through the middle. Which one, red or blue? Yeah, that's right. The red one is the radius. What's the blue one called? Diameter. Okay, great. How much space do we need? Okay, what are we talking about here? When I talk about how much space does our garden need, am I talking about the fence around it? Am I talking about the area inside? What am I talking about? Okay, let's see how many people get it right. Let's see. I'm talking about area, talking about circumference. What are we talking about? Okay. What are we talking about? We're actually talking about area. So anytime you see the word space, how much space do you need? Space is a two-dimensional area. Two-dimensional area. Area is how much space that circle is going to take up. Good. So area is a formula. I'll give it to you. Pi r squared. We already practiced a few times with this, so let's do some more. Okay. How big is my circle? It is 28-foot radius. That's big. That's big. How big are you again? You're like 4 feet, maybe 5. Some of you who are a little bigger. 3 feet. Some of you who are more my size. Area is pi, 3.14. And what do I put in here? Do I put 28 times 2? What do I put in? What do I put in for the r? That's right. I put in 28 feet, and I'm going to square it. So most of our time is drawing the picture, thinking about the problem. Okay, space, that means area. Okay, so I know that. Okay, and then figuring out the formula, writing it down, thinking about what I'm putting in here. That's most of the problem. The last 2 seconds are this thing. 28, let's see if I can put it over here. 28 squared times 3.14. So that is 2, 4, 6, and I'm going to round this up to the nearest whole number. And the units are feet squared, because that's feet squared. So we have a garden that is almost 2,500 square feet. That's a nice big garden, by the way. We could plant some good trees in there. And maybe berry vines, yeah, around the outside. Would that be good? Blueberries, raspberries, blackberries. Yeah. So in my previous house, we had wild blackberries up the drive, and people would literally come with their cereal bowls from my neighborhood, have their cereal, walk to my house, pick the berries, and put them in their cereal. And I remember thinking, why are people gathering our berries? It was clearly our property. They would just walk up. You know, it wasn't like we were out in the middle of nowhere. It was like a city block. But they would come up, and there was big. They were bigger than I was. They were huge. But they were there first, and then they had built the house there like 30 years ago. And yeah, I remember going out one day, and I'm like, "What you doing?" And the guy was like, "Oh, yeah, I was enjoying some fresh berries." I'm like, yeah, but I drew the line when the lady started coming with the big cartons, and she was like filling them up so she could make pies and jams. I'm like, hey, those are ours. Feel free to enjoy like a few. I'm good with that. I don't mind. But really, like, you're just going to strip the bush? I don't think so. Yeah. Okay. There was a mini story for you. Okay. So how are we feeling about this? Are you getting a little more comfortable with word problems? Okay. Let's tackle 2 more, and then we're done. Okay. I know. How's it? You guys like circles? Yeah, I'm getting a lot of smiles about the circles. Okay, good. So if this is not making sense, don't worry. We've got a couple more problems. And we have lots of fun activities for you this week. All right, how many of you like space travel? Anybody want to get in a rocket ship and go to space with me? I'll drive. No, you wouldn't go with me? No, well, okay. I'll take pictures and send you a postcard. Okay, so we're on Titan. This is real. This is the biggest moon of Saturn, and we're cruising along. We land on the surface, and we're cruising along in our little speeder, and we go all the way around the equator, okay? And we look down at the odometer, and this is how far we went to make one trip around Titan. Now, this is a real number, by the way. This is what they've measured. They didn't actually land on Titan and use a speeder, but this is what they've measured, okay? Question, what is the radius of Titan? Okay, so what did they measure? Okay, so this is a 3-dimensional object we're thinking about now. 3-dimensional object. Okay, so I have this is really big on the screen. Here, come back up here. So, all right, so we got on our speeder and we went all the way around once. So are we talking about area? Are we talking about, what are we talking about for this one? Talking about perimeter, circumference, radius, diameter. What's your guess? So what do you think? You'll take a postcard? Okay, that's fine. All right, so yeah, we're talking about circumference is what we're talking about. We just made one trip around. Okay, so we're not talking about how much space it takes up. We actually just traveled, we just walked. We went around. So that path is perimeter. So let's go. You wouldn't want to go? This is the one that has the nitrogen atmosphere is so thick that if you were to strap cardboard onto your arms and flap, you would actually fly for real. So yeah, now you want to go. Okay, so all right. Okay, so this number is circumference. Oh, we could spend all day talking about the moons of Saturn. They are like the coolest moons in the entire solar system. Okay, so we have a few different equations. We have 2 pi r, and we also have pi times d. Okay, so which one do we want to do? So since we're looking for the word radius here, you see that? Radius? I would choose this equation right there because it's got radius built in. Okay, so I want to get radius by itself because they've given me this number, 10,052 miles is circumference. I know 2, pi is just a number, 3.14. I don't know r. So what I'm going to do is I'm going to divide both sides by the stuff I want to get rid of, okay, and that will get it unmultiplied by r. And then I just shove it over here. It's kind of like kicking things under the bed when you don't want to put it away. You just kind of shove it over there. 2 pi over 2 pi, that gives you 1. Okay, so this is 1. And so here, I'll put the 1 down here. All right. So then all I'm left with is radius. So I'm going to rewrite that here. Radius is c over 2 pi. And if you didn't follow that, just grab this equation and use it. We're actually going to talk more about 1-step and 2-step equations in a few in our algebra class. Okay. So my radius is equal to circumference, which is 10,052 miles, divided by 2 times pi. All right, so think about what we did. We landed on the surface. We took 1 trip around the equator. We measured how far that was. And we want to know how big's the planet. That's reasonable, right? You could, if it was solid and you had enough time and water and supplies, you could walk around and get this measurement, sure. Okay, and this would tell you exactly how big the radius was, provided this thing was a sphere. Okay, so then we have, we rearranged our equation. C is equal to 2 pi r. We rearranged it. We took the 2 pi and threw it over here. C is, by dividing both sides of the equation by the same number, that got rid of the 2 pi. That made it turn into 1. So all we have left on this equation is r. Here, I'll circle it. R, which is here. Okay. So that's r equals, because this is just 1, c over 2 pi. And then this is our distance divided by 2 divided by pi. Who's got a number for me? Did I give you enough time to calculate? 10,052 divided by 2 divided by 3.14. I get 1,600. And what are the units? Ooh, extra credit. What are the units? That's right. It's right here. You see right there? Those are my units. Miles. So the radius is 1,600 miles. That's a huge radius. That's why it's the biggest moon of Saturn. Good. Okay, good. All right. How many of you have ever gone on a road trip? And depending on where you live, you may see these and you may not. Yeah, I'm trying to answer all the questions that are coming in. So do ask questions as we work through it. Last problem we're going to do together. You're on a road trip and you see these big structures. It's a center pivot and they go around in a circle, and it's a sprinkler system, and they have little wheels on the end. You ever seen those before? If you haven't, they're super fun. You can look them up, and what they do is they have these little sprinklers that are hanging down, and it's got a big water pipe on the top, and it's connected to the middle. And so here's the middle, and so this thing will swing around, and it'll irrigate in a circle. And sometimes they go the full circle, and sometimes they only go part of a circle, like you can see here, things different. They've planted different things. And sometimes they'll do a circle within 3/4 of a circle. So just depending on what they're planting. Okay, so it's called, that system is called a water wheel and circle irrigation machine. Usually it's just a irrigation machine, circular irrigation machine. Okay. And the equipment rotates around the center pivot, and the crops are watered. Okay, the center, now this is a whole lot easier than watering by hand. Wouldn't you agree? Yeah, we like that. Okay, so question. The center arm uses a pipe that is 1,600 feet long. So same number, but just the units are different. Okay, 1,600 feet long. How much area will the water cover? Okay, so we're looking for, you see that magic word right there? Area. All right, you should be thinking area. Area, where is my area? Is pi r squared. There's my formula for area. Okay, what do I know? I don't know area. That's what it's asking me for. Okay, good. Equals, I know pi, that's a number. Do we know r? Yes or no? Okay, reread the problem a little bit. The last sentence, what does it say? The center arm uses a pipe. Okay, so this is where pictures come in handy. So this is what we're going, it's a giant circular garden, basically. The center arm starts from the center and goes out to a point on the circle. And then that whole thing is going to sweep around in water. Question, is that blue center arm a radius or is it a diameter? What does it look like to you? It's a radius, isn't it? And we already gave you the dimensions. The center arm uses a pipe 1,600 feet long. So this is going to sweep. This is a giant arm. Would you agree? Yeah, my arm is not 1,600 feet. If it was, I wouldn't fit in your house. Okay, so this thing is going to sweep. So this tells us the arm is that much. Good, which is exactly what we want here. If it was diameter, we just divide it by 2 to use it. Pi, I could just put the number in. Hang on. Get my eraser. Okay, so 3.14 times 1,600 feet, and that's squared. All right, notice we spent a lot of time thinking about the problem, coming up with an equation, checking to see if it's the one we want, drawing out what the problem is saying. This is what I want you to do this week. Okay, so take your time. It's often deceiving when you watch a teacher do word problems for that reason, because it's like, how do they know that to do that so fast? You need to sit with this for a while. And so I hope this is coming across pretty well, that it's okay to think about problems for a little bit, even get up and get a snack and think about it on the way to the fridge. All right, so once we've got that, we check it. We say, okay, this is pi. Is this really radius? Is that really what it's saying? Yeah, okay, it is. All right, so 1,600 feet, I'm going to square it. So 1,600. If you don't have a square button on your calculator like I do here, you just do times the same number. It'll give you the same thing. All right, we got a lot of zeros, and then we're going to multiply it by pi times 3.14. And we write this whole thing down, 8038400. Just write the whole thing. Put the units, feet are squared, and then you put the commas in. 1, 2. So can you say this number out loud? What's this number? 8, and then what's the thing that you say after it? 8 what? 8,000? 800,000? No. 8, that's what 8 million looks like. So we have a garden that is 8 million square feet. Imagine what you could plant in an 8 million square foot garden, right? So good. So many good things. Everything you guys want and probably more. So yay! All right. And let me see if I got the units right on that one. Yes, I do. Okay, good, good, good. All right, so how are we feeling about area and circumference, and what else are we doing? We did perimeter, circumference, and diameter. Yeah, feeling pretty good about it? Good. All right, so let me show you what you get to do for your work this week. And if you have more questions, you're asking them now so I can answer them. I think I answered most of them. And I have a fun story for you, of course. Okay, so we're all done. Shake it out. Put it down, give me a big old smile. You like circles? I got this. I got the circle thing. A little bit of practice maybe, but yes. Okay, good. All right, so let me show you where on the website you're going to click. So you're going to go to the math website, and you're going to go to the mini math course. Click on geometry. Oh, sorry about that. I don't have a mouse yet. Let me click it on. Okay, so you're going to click on mini math course and then geometry. And then you'll be taken to session 1. Click on session 4, and then you'll be taken to this page. Okay? All right, so circles, and then scroll down, and do you see these 2 buttons? The first one has the math assignments. You click on it, and this page comes up. So we want you to do workbook pages. Look at this. There's only 5 workbook pages today. For this week. You could do 1 workbook page every day, and that you'd be good to go. So there's 5 workbook pages, 37, 38, 39, 40, 41. Oh, no, 6. Sorry, 42. Forgot to add 37. Yep, so 6 workbook pages. Okay, so you're going to work on that. There is a packet that talks about circumference and area. So if you're still a little shaky on that, this is an excellent packet to do. And then we have some fun stuff. All right, so let's scroll down. Here's your workbook. If you want me to walk through the workbook with you, absolutely. The last 2 pages are a test because you are now testing out of that workbook. Yay! All right, and you'll get a new workbook next week. Okay, so then we've been in that workbook for 3 weeks now, I think. So yeah, you're done. So finish it up. All right, so then there's a packet. These packets are actually really good. I want you to take a look at the packets when you're done. And then we have an activity. How many of you like to do like fun stuff, not just sit at a desk all day and just do calculations, right? You have to get up and have some fun. All right, so when I do this one with a real class, we have all kinds of things that I bring in. I bring a big old box of stuff, and then we have a race and we have lots of fun trying to figure it out. And so this is a circles activity, circumference and area. Get you comfortable with both. So you're comfortable knowing when it's circumference, when it's area, when you should use each one. Okay, and then how many of you, where are my maze kids? Kids that I could drop in a maze and you'd be happy all day. Mazes, there we go. Okay, good. So we have mazes this week you can do. Solid color. I got, my daughter is a colorer. She will color all day long. She'll color the walls if you let her. Okay, and then bingo. And then we also have a challenge. Have you guys been liking the challenges so far? Remember the trading corks? So this one is center the cork. So these are really good to do with your family during dinner. So kind of as things are winding down, you can say, hey guys, you want to help me with my math homework? Watch this. And you can bring this challenge to them. And basically it's a cup of water and a cork and you have to center it just by dropping it. And it's super easy, super fun, and you can see what your family does with it, and then you can just sit back and smile because you've already figured it out. Okay, and then the mirror symmetry problem is another challenge. So because we're in geometry, you're building things, you're puzzling things, you're doing some fun stuff. So yay! All right, so that's what I have for you for this week. The outline during class, you get that just by clicking on this button here, the second one. That's where you'd find it, and here is this is the handout we used in class, okay? So notice that it stops right now, so as soon as we're done with class, I'll scan my pages and add it to the back of this one, just in case you missed one or you'd like to see my notes. All right, good. Okay, you guys ready for a story? Here we go. We actually have been, where is it? I have been collecting stories. Look! I've been writing all of them down, the ones that I share with you, so I can just look at them now and say, hey, have we done the flying flaming strawberry? Have you guys done that one? Okay, so now you are relaxing, you are taking a snack break, you are putting your feet up, not on the camera, that's rude. All right, so here we go. Once upon a time, there was a teacher, me, who decided I was going to go home and practice some chemistry experiments. Because I was going to teach chemistry the next day. Hang on. There, I think that's better. You ever just get something stuck? Yeah, there it goes. Okay, so I'm at home and I'm practicing my chemistry experiments, and so I did a lot of work in rocket engines. Many of you know I used to work for NASA. So combustion it's just my thing. Gas dynamics. I would take extra math classes extra classes like in propulsion and design and stuff. And then I would have to take extra math classes to understand what I was designing. So I was at my kitchen sink when I was a graduate. Was I a graduate student? Maybe, or I was just beginning to teach at Cal Poly. And so I'm sitting there and I'm mixing up chemicals, good ventilation, everything's going well, and I can't get the experiment to work. And you put the look on your face when you just know it can work and it's just not working. You're just like, right? You're just like, So I was kind of making that face. And so I thought, you know what? This is just not going to work. So I just leave it, right? And I leave it in the sink, in this big stainless steel sink. And then later, my husband is cutting strawberries, and he's cutting he's cutting the tops off of them, and he's throwing them into the sink. And every so often you get a rotten one, so that goes in because that's where the garbage disposal is. So he throws it into the sink, right? And he's trying to make it into the garbage disposal each and every time. All right, so I go back and I forget that he had been doing the strawberries, and he was on the other side of the counter, so he was just tossing them in, right? So there's strawberries and stuff in the bottom, and I forget that he was doing that. And so I kind of scooped them into the bottom and kind of forgot about it and came back, and I was like, you know what? I'm going to try this experiment again. I said, you know what? Maybe my ignition source isn't sustained enough. I was just using like a spark igniter, and it was a combustion experiment with propane. And I was like, maybe I need something more constant. There's like a candle flame or, a propane torch or something. So fortunately I didn't use a propane torch. I go to light a candle, and I'm lighting the match on the candle, and then I throw the match in the sink, right, to extinguish it. And I throw it in the sink. All of a sudden, the strawberry stems go whoosh up to the ceiling, just boom. So I apparently had generated, so propane is heavier than air, and so if you have a cloud of it and you don't ventilate it properly, which is what I didn't do, all of it just sits in the bottom, and it had crept down into the pipes, into where the strawberries were sitting, got under them. You can imagine. So basically, yeah, so the strawberries are on the ceiling. My husband comes running upstairs. He's like, you didn't wait for me. He's like, what? I was gonna watch you. And I'm like, I wasn't ready yet. He looks at the ceiling and he's like, what did you do? Oh. So safety first. That way you're still here to do more science experiments later. So that's the story of the flaming strawberries. Yay! And so when you do this for real, you do it in a lab. You don't, you always have proper ventilation, and which of course I didn't have. I should have done it in the chemistry lab that I had access to. I just figured I was home, I was going to try this, and I never tried it again. So yes, we don't want to blow my house apart. Okay, so there you have it. Aurora and the flaming strawberries. Okay, so you have your work this week. You've got some of your pages to finish. And if you have any questions, you're going to let us know. Doug is going to see you on Wednesday. And then when we get together next week, we are going to do a brand new workbook that I have available for you. And I'll post that later this week so you can print it out in advance and everything. Okay, let's see. Do you get a spring break? Yes, right now, from now till next week. Enjoy. No, we actually don't take, yay! I don't take time off spring break because everybody's spring breaks is different. So that's just it. We used to, and it was just too difficult with the science program. And so we just teach all the way through. So feel free to watch the recordings obviously, if you get to this part of the class and you're not here, you're watching the recording. So you can watch the recordings and just make up the time when you need to. That's totally fine. And so remember, no Leah this week, but yes, Leah next week. And so she is on her official spring break. So yay! So go enjoy. I hope this class in circles was fun. Go enjoy some of the challenges, the projects that I have for you, and I will see you